Alright, so 9 and 10. We are looking at 9 and 10. First of all, the homework that is due for next class, I want to make sure that you understand, I'm not going to go all crazy on the transformation because you learn it next class, okay? You will learn by name, by correct name, what I'm looking for. But for now, just try to describe it to what you feel is happening, okay? These two examples, some of you might learn it already, just from these two examples of the big main ones that I'm talking about. And if you learn it early, that's okay, okay? But whenever I grade, when we grade over this, I'm not really going to stress the transformations, but I will stress everything else, all to the detail, okay? So here we go. Number 9. The big part that I want you to understand is that this negative is on the outside of f of x, okay? So f of x is the original function, okay? This is where you started at on the graph. So the original function is this one right here, the absolute value of x, okay? That is the original function. You with me? Now, we're going to change the original function. Now, the analogy that I gave you guys, there's a lot of rules to memorize for transformations. There's a lot. And I've condensed them down to 3 with one little asterisk. And if you follow and you, bless you, if you learn all those, just this 3 from like 10 or 15 or whatever it is, you can condense it all just to those 3 with that one caveat. And it's a lot easier to memorize, okay? And it works for all of them. So here's the thing. If my equation is f of x, bless you, aka absolute value of x, anything that happens inside the x, and you saw this with the video, anything that happens with the x, you do the opposite. Okay? And yes, I use the analogy like ex-boyfriend, ex-girlfriend, ex-wife, whatever. You did the opposite, that's why they're your ex. Okay? So, with that in mind, you're going to interpret everything as opposite. Okay? However, if it's outside, basically with the y value, you're going to follow the rules. Okay? So, here we go. X is left and right, and we're going to interpret the opposite. Where y is up and down, and we're going to follow the rule. Okay? So, let's say that I had an equation that looked like this. Let's say that I had an equation that looked like this. My original parent is x. This 3 is horizontal change. So that means it's left or right. What's your first intuition when you see -3? To go to left or right? Left. That's your first intuition. But I told you, if it's with your x, you're going to do the opposite. So you're not going to shift to the left 3. You're going to shift to the right 3. Okay? But everything on the outside, because again, everything with the x, we do the opposite. But everything on the outside, we're going to follow the rule. Okay? Everything on the outside is y movement. That's up and down to some extent. So in this case, we're not going to do the opposite and go down 5. We're going to shift up 5. Because everything on the outside, we follow the rule. Okay? And you'll get more of this. If you didn't just get that, no worries, because you're going to learn it deeply next class. Okay? Okay, here we go. So, I have a negative on the outside, so g of x should look like this. That should be your function. Okay? And Pemdas is huge. Right now, Pemdas, you're going to refine and master and make sure that you refine it before the end of this unit, is that the order of operations is I'm going to plug in, let's say -3, -2, -1, 0, 1, 2, and 3. And I'm going to plug all of these values in for x. So the steps are, let's plug in a -3. What do these do to the -3? Make it positive. And then if I multiply that by a negative, I get -3. Go with me? So let's graph that as we go. A -3 will look somewhere around there. I just graphed it as if it was a point. Okay? Order of operations. Let's plug in a -2, where the x belongs. The absolute value signs make the -2 into a what? A +2. A +2. And then I multiply it by this negative to finally get a what? A -2. What will the -1 become at the very, very end? -1. What will the 0 become? 0. Is 0 ever positive or negative? No, it's neither, okay? And then 1, what would 1 become? -1, and then -2, -3. So that I have -2 is here, -1 is here, so on and so forth. You're just plotting all these points so that the graph looks like this. Okay? What's the domain of what you see right now? All real numbers. And yes, if you wanted to do the interval notation, you could have done -infinity to infinity. As interval notation, what's the range? -infinity to 0, with bracket at 0 and parentheses. As an inequality, remember what I said. Go ahead. Y is less than or equal to 0. As an inequality, if you put this like that with that -infinity, I'm going to count off on points next test. So please make sure that you don't do that. You don't need all that extra stuff. You just have to say what Ashton said, y is less than or equal to 0. Okay? From the video, x-intercepts, immediately I want you thinking what? Y equals 0. Okay, write it down. Y-intercepts, I want you to immediately think of what? X equals 0. Okay? So, think of the x-intercept. When does y equal 0? No, not 0. Don't just say 0. Be more explicit about what we talked about in the video. X equals 0, right? Because this is talking about, if you were to list it as a point, I want you to know what this means. And I've stressed it in the video, okay, of the importance of that. The y-intercept. The y-intercept, this one, x is equal to 0. So what does y equal? 0. Y equals 0. Yeah. So you're going to put y equals 0. And again, you're stressing the fact that you understand from a point what that means. And you're going to see this for the rest of the year, okay? It's very important to just get it down right off the bat. Axis of symmetry is what? X equals 0. Slice it right down the middle, right? Axis of symmetry, you're just slicing down that red graph right down the middle. But again, this is why you can't put 0, because if you put 0 for everything, I don't know what you mean. I don't know if it's x equals 0 as a point. I don't know if it's y equals 0 as a point. I don't know if it's x equals 0 as a vertical line. You see what I'm saying? So you got to be very careful to write that out, because they mean different things depending on their context. Elijah, what's the vertex? 0, 0. Apurva, does this have a max or a min? A max. Okay. Fernaz, what is the max value? What would you write on a quiz? Y equals 0. Nice. Okay? Because again, here's the point, and I'm talking about that's the max. Okay? Anyone from the video, if the y gave you what it was, what did the x give you? Where it was. Where it was. When it was. Time-wise. Okay? And that's big going into physics and calculus. Alright. So, the slope. Again, some people were a little confused on this. I'm talking about from -infinity all the way to 0. So, what is the slope that you see on the red graph on that interval? Anyone? 1. A positive 1, right? So m equals 1, and what was the two-letter important word that came after that? On. So m equals 1 on, because it's an interval, and you're going to say negative infinity to 0.
So we have to have that thing.
Yes, I want you to have it that refined, okay? Because guys, we want calculus to be easy when we get there. Not learning all of this and relearning it when we get to calculus, okay? So, what's the slope equal, not on, but at x equals 0? It does not exist because it's a corner, it's a cusp, okay? They call it a cusp. And you can write that down if you want, C-U-S-P. So M equals does not exist, and not on, but what did I say? At x is equal to 0. And yes, M is equal to negative 1 on 0 to infinity. And the transformation is this. From the original orange graph, what happened? It reflects across the x-axis. And you can see this because this was outside of x. That means it's vertical change. So it's a vertical reflection across the x-axis. Okay? This is very similar to number 10. The only difference is the negative is on the inside. So just follow the way we just did this, but with the negative on the inside first. You with me? So just to get you started, you would put this negative 3 into number 10s, because I'm running out of time, I'm going to do it this way. And if I plug in a negative 3, this negative will make it turn into what? Positive. And then the absolute value keeps it positive. It doesn't undo it. Do you understand? The absolute value is to make it positive no matter what.
So it's inside, no matter what it is always just.
Yes, it will become a positive after you apply the absolute value.
Even then it's still positive.
Yeah.
Okay.
Are we good? Do you understand that? Some people think that if it's negative, it makes it positive. But if it was positive, it makes it negative. No.
So the negative means nothing.
The negative means the negative means nothing here. Listen, before you put up, the negative means nothing here. Graph it out, and you're going to see that the graph will end up becoming the same exact graph because it was a horizontal reflection. Look at my hands across what? The y-axis. Are we good? All right, guys, go ahead and put up.